homogeneous differential equation. Let us see what is homogeneous function. A function f x comma y is said to be homogeneous of order n if f of lambda x comma lambda y can be written as lambda raised to n f of x comma y, or f of x comma y can be written as x raised to n g of y by x, or f of x comma y can be written as y raised to n into g of x by y. See here, a function f of x comma y is said to be homogeneous function of order n if f of lambda x comma lambda y is equal to lambda raised to n f of x comma y. So what is meaning of this here? अगर हम कोई भी फंक्शन में x और y के बदले में लैम्डा x और लैम्डा y रिप्लेस करते हैं तो उस फंक्शन को लैम्डा रेज़ टू n f ऑफ x कॉमा y ऐसा लिख सकते हैं. So if given function is of order n, then अगर समझो कोई भी फंक्शन के ऑर्डर n है, डिग्री n है, और हम लोग लैम्डा x और लैम्डा y x और y को रिप्लेस करते हैं और अगर इसको हम ऐसा लिख सकते हैं तो then that function is called homogeneous function. So for example, see here, we will write here f1 x comma y is equal to y square plus 2xy. So what is degree of this function? So degree of this function means degree of each term here, degree of each term involved in this function. What is degree of y square? It is 2. Degree of 2xy is, that is 1 plus 1, 2. Now here f1 lambda x comma lambda y is equal to lambda y square plus 2 into lambda x into lambda y. So this can be written as lambda square y square plus 2 lambda square xy. So this is equal to lambda square y square plus 2xy. Now see here, y square plus 2xy is nothing but f of x comma y. See here, you can say f1 x comma y. So this function can be written as, means f1 lambda x comma lambda y can be written as lambda square f1 x comma y. Therefore this is homogeneous function. Or here, this function can be written in this term also, in this form also. Let us see here. f1 x comma y is equal to y square plus 2xy. तो यहाँ पर हम लोगों को x square कॉमन निकालना है. x raised to n means x, here degree of this function is 2. So take out x square common. So take out x square. So it will be y square upon x square plus this will be 2y by x. So therefore this is equal to, so is x square raised to x square into g of y by x. ये जो ब्रैकेट के इनसाइड में जो फंक्शन है इसका वेरिएबल y बाई एक्स है. सो दिस फंक्शन कैन बी रिटन एज x square into g of y by x. Therefore, this function is homogeneous function. Or this can be also written as, हमको इसको ये देखना है. So what is this here? f1 x comma y is equal to y square plus 2xy. So what is degree of this here? 2. So take out y square common. So y square common. So it will be 1 plus 2 x upon y आ जाएगा ये. So this is y square h of x by y. तो y square plus 2xy is a homogeneous function. हम लोगों को क्या करना है कि इसको whether given function is homogeneous or not ये डिसाइड करने के लिए उसको ये तीनों में से एक टाइप में लिख सकते हैं या नहीं ये देखना है. किसी भी एक टाइप में अगर हम लिख सकते हैं then we can say that given function is a homogeneous function. Now let us see one more another function here. f2x comma y is equal to cos of y by x here. Now ये तीनों में से कोई भी एक मेथड यूज करेंगे हम लोग. Okay. So what is degree of this function here? Degree is 0 degree. Degree of y is 1. Degree of x is 1. Therefore degree of y by x is 1 minus 1 0. So I'll write here f2 lambda x comma lambda y is equal to cos of lambda x upon lambda y upon lambda x. This lambda will get cancelled. So I can write lambda raised to 0 cos of y by x. So this is equal to lambda raised to 0 f2 x comma y. So therefore I can say that I have written this function can be written in this form. So therefore cos of y by x is a homogeneous function. इसको ये दोनों टाइप में भी we can write. Now let us see one more function here. f3 suppose x comma y is equal to cos x plus sin y. Cos x plus sin. What is degree of this? Degree of this here function we can say that 1 degree. Okay. So f3 lambda x comma lambda y is equal to cos of lambda x plus sin of lambda y. बराबर है. जहाँ पर x है वहाँ पर हम लोग lambda x और जहाँ पर y है वहाँ lambda y. So we cannot take out here lambda common. We cannot take lambda common. So this is not equal to lambda into f of 3 x comma y. Okay. So therefore this is not homogeneous function. Okay. Now let us see what is homogeneous differential equation. An equation is said to be differential equation instead of right differential equation is said to be homogeneous if dy by dx is equal to x raised to n y by x. Any function which can be dy by dx is equal to, I'll write here simply, dy by dx can be written as g of y by x. G of y by x. Okay, where g of y by x is a homogeneous function. G of x is a homogeneous function. Okay. Now let us see how to solve this differential equation. Dy by dx is equal to g of y by x, or I can write here, I will repeat this. Differential equation is said to be homogeneous if dy by dx is equal to f of xy, and this can be written as g of y by x, or it can be written as, or I can write, or dx upon dy is equal to f of x comma y is equal to h of x by y. तो कोई भी डिफरेंशियल इक्वेशन इस फॉर्म में अगर हम लिख सकते हैं तो differential equation is called homogeneous differential equation. What is this? F of x comma y. F of x comma y is a homogeneous function. Dy by dx is equal to homogeneous function. That differential equation is called homogeneous differential equation. So let us see how to find solution of this differential equation. First we will see of this type. अगर इस टाइप में differential equation है तो how to solve this? Here put y by x is equal to v. Differential equation is of this form. Then for this first step, put y by x is equal to v. So this implies y is equal to vx. So then what we have to do here? We have to differentiate this with respect to x. Now differentiating this with respect to x, dy by dx is equal to first function into derivative of second is 1 plus x into dv by dx. So call this as equation number 2 or this as equation number 1. So using equation number 1 and 2 we can write dy by dx means what? V plus x dv by dx is equal to, this is g of y by x means v, g of v. So this can be written as x dv by dx is equal to gv minus v. So this can be written as, now it is in variable separable form. So this implies a v और x वाले टर्म एक साइड में लेना है, तो I can write 1 upon g of v minus v dv is equal to 1 by x dx. So if we integrate this, now integrating both sides, then we will get plus. So this equation number 3 is called general solution or primitive of equation number 1. तो इस मेथड से हम लोगों को क्या करना है, डिफरेंशियल इक्वेशन को सॉल्व करना है। अगर गिवन डिफरेंशियल इक्वेशन इज ऑफ दिस वन dy by dx इज इक्वल टू g of y by x, ठीक है। नाउ लेट अस सी इफ गिवन फंक्शन, गिवन डिफरेंशियल इक्वेशन इज ऑफ द फॉर्म, यहां पर अगर समझो ऐसा है, dx अपॉन dy है और यहाँ पे विल टेक h और यहाँ पे dx अपॉन y है। तो यहाँ पर क्या करना है कि पुट x अपॉन y इज इक्वल टू v लिखना है। So this implies x is equal to vy. Now differentiating with respect to y करना है यहाँ पे। So derivative of x with respect to y is dx upon dy is equal to first function into derivative of y with respect to y is 1 plus second function into dv upon, we have to differentiate this function with respect to dv upon dy. Okay, so call this as equation number 2. So from equation number 1 and 2, what is dx upon dy means, I can write this v plus y into dv by dy is equal to h of v आ जाएगा। So this can be written as y dv upon dy is equal to h of v minus v. Again it has come in variable separable form, तो इसको फिर y और v के टर्म एक साइड में लेना है। So it will be 1 upon h of v minus v dv is equal to 1 by y dy। तो इसको हम लोग इंटीग्रेट करेंगे तो उसके बाद में ये जो आंसर मिलेगा, आंसर विल बी इन दिस फॉर्म। सो दिस इज कॉल्ड solution of equation number 1. Equation number 1 means what? That is differential equation. This is solution or primitive of differential equation. This is general solution because C is any arbitrary constant. So in this way we can solve homogeneous differential equation. Okay, so let us see here one example here. Let us see one example. So show that x cos of y by x dy by dx is equal to y into cos of y by x plus x. देखिए is homogeneous equation, is homogeneous differential equation and solve it. इसको सॉल्व करना है हमको। तो होमोजेनियस डिफरेंशियल इक्वेशन, हाउ टू मीन्स अंडरस्टैंड दैट गिवन डिफरेंशियल इक्वेशन इज होमोजेनियस डिफरेंशियल इक्वेशन। तो डिफरेंशियल इक्वेशन में अगर y by x और x by y कहीं पर भी है तो we can say that given differential equation is a homogeneous differential equation. एग्जाम में आपको you will be given differential equation or you will be asked to solve it. It will not be given that दिस इज ए होमोजेनियस डिफरेंशियल इक्वेशन एंड सॉल्व दिस। अभी यहाँ पर ये क्वेश्चन ऐसा है कि प्रूव दैट दिस इज ए होमोजेनियस डिफरेंशियल इक्वेशन। सो लेट अस सी हियर, we'll write first this can be written as here x cos y by x dy by dx is equal to y into cos of y by x plus x. So this can be written as here dy by dx is equal to y into cos of y upon x plus x upon x cos of y by x. तो इसको होमोजेनियस डिफरेंशियल इक्वेशन बताना है, तो हम लोगों को ये जो फंक्शन है इस फंक्शन को होमोजेनियस फंक्शन बताना पड़ेगा, ठीक है। सो लेट अस टेक आउट हियर x कॉमन फ्रॉम न्यूमरेटर हियर, टेकिंग आउट x कॉमन, so it is cos of y by x plus 1 upon x into cos of y by x. Now see here, this I can cancel this x cancel, बराबर। So therefore this can be written as x raised to 0, see here this can be written as x raised to 0 g of y by x. So as this function can be written as x raised to g of y by x, therefore dy by dx is equal to x raised to 0 g of y by x. So this implies given differential equation is homogeneous differential equation, ठीक है। ये होगा दिस इज शो दैट दिस इक्वेशन इज homogeneous differential equation. Okay, now we have to solve this differential equation. So let us solve this differential equation. Now how to solve this differential equation here? So we'll take out first y common here, x common. So dy by dx is equal to, taking out x common, so it will be y by x cos of y by x plus 1 upon x into cos of y by x. So this will get cancelled. Call this as equation number 1. इसको इक्वेशन नंबर 1 लेना है। now इसके बाद में क्या करना है, so put y by x is equal to v करना है। so this implies y is equal to vx. so y is equal to vx, इसको डिफरेंशिएट कीजिए विथ रिस्पेक्ट टू x, डिफरेंशिएटिंग विथ रिस्पेक्ट टू x करना है। so what will be this, dy by dx is equal to first function into derivative of this is 1 plus second function into derivative of v dv by dx. so call this as equation number 2. so using equation number 1 and 2, using equation number 1 and 2 means what, dy by dx के बदले में ये लिखना है, और जहाँ y by x है वहाँ पे क्या करना है, y by x is equal to v लिखना है। so therefore I can write here this v plus x dv by dx is equal to, this is v into cos v plus 1 upon cos of v. Is it clear? now I can write this as this, yes, so I can write this as x dv by dx is equal to v cos v plus 1 upon cos v minus v आ जाएगा, बराबर है। So this can be written as v cos v plus 1 minus v cos v upon cos v. So this I have multiplied this v. So I can cancel this now. So I can write this as x dv by dx is equal to 1 upon cos v. Now this is in now variable separable form में आ जाएगा, बराबर है? So this can be cos v dv is equal to 1 by x dx. तो इसको now let us integrate both sides now. Integrating both sides. What is integration of cos v is sin v is equal to log of mod x plus c can be written as log of c. कांस्टेंट को हम c ले सकते हैं, तो इसके बाद में इसकी स्टेप ऐसी, this can be written as sin of v, v means what, y by x is equal to log of c here, log of m plus log of n means log mn, log of mod of cx I can write. Okay, so this is the general solution of given differential equation, or this is called primitive of given differential equation. ठीक है? Okay, thank you.